Welcome back, guys, to lesson 2.2 about solving literal equations. We've got a short video for you today. This is going to be just like solving regular algebraic equations. The only difference is we have all or mostly variables. Basically, a literal equation is an equation with more than one variable, and you will typically have to solve for one of those variables. So, for example, one that you'll see pretty often, and you'll see when you get to some physics classes and chemistry classes, stuff like that, Ohm's Law, voltage equals current times resistance. So there is an equation for Ohm's Law, which is V equals IR. You'll also see stuff like density equals mass over volume, just other equations involved in physics and chemistry that involve a bunch of literal values, so a bunch of variables. The reason we have a bunch of variables here is because I want to be able to find voltage in any situation, and that voltage is dependent on the current times resistance. So if I know that V equals IR, I want to solve this equation for I. So V equals IR. So I want to solve this for I to basically say, if I know the voltage and resistance, how do I find the current? So this is pretty simple. If I want to isolate I, R is being multiplied by I, so I'm going to use that division property of equality. Divide both sides of the equation by R, and I'm left with I equals V over R. So now this gives me an equation that gives me current in terms of voltage and resistance. So again, these equations are just like any other algebraic equation. The only difference is that these values are variables instead of numbers. So V over R, I don't know what V is, I don't know what R is, but I'm gonna leave it as V divided by R. So let's take a look at another one. So A times B minus C equals MV. I'm gonna solve for C. So I've got A times B minus C equals MV. So one thing that's useful when you're solving these literal equations is first try to determine what variable it is you're solving for. So I'm solving for C, which means I need to get C alone on one side of the equation. Right now I notice C is inside these parentheses. So it's going to help me if the first thing that I do is use the distributive property of equality to distribute A into this. So I get AB minus AC equals MV. So now that I know this, I see C is what I'm trying to isolate. So I need to move AB over the other side of the equation. So I'm going to use the subtraction property of equality to subtract AB from both sides of the equation. If I notice MV and AB are not like terms, so I can't subtract them from each other, so I'm just going to leave it as MV minus AB. So I've subtracted AB. I'll write this out for you so you can see what we're doing. Now, and then I distribute it up here. So now I'm going to use, I notice that I still have A times C. I have negative A times C. So what I want to do now is I'm going to divide by negative A. So I'm going to divide both sides of the equation by negative A. And so I'm left with C is equal to, when I look here, MV over A. This is negative MV over A. There's nothing else that I can do with that. But over here, I notice negative AB divided by negative A. A divided by A is 1. And then a negative divided by a negative is a positive. So this is just MV over A plus B. So now I've isolated C, and C is going to be equal to negative MV over A plus B. So that is it for today's lesson. We just talked about solving literal equations. Remember, as I've told you before, these videos are not meant to be all inclusive. This shouldn't be the only thing that you do. We're going to go through some more examples in class so that we can practice with this. But today we just looked at a couple examples of solving literal equations, and I made sure to mention the properties of equality that we were using along the way so that we can reinforce those properties of equality we talked about last time. So if you have any questions, be ready to bring them to class. Hope you took some good notes, and I hope to see you soon.